So, like I said, this is it for Unit 6. Last little bit. We're talking about inverses. We are talking about quadratic in standard form. These functions, they're in standard form. Ax squared plus bx plus we cannot see x. We for the domain and range. We learned that was last week. A couple of lessons ago, we learned how to do negative b divided by 2, find the x value, plug it back in, y value, and we find the vertex and figure out the domain and range that way. But if we want the inverse, we actually need more than that. Called complete square. Our quadratic standard form, vertex form, because that will eliminate this double x term. So we've got two x terms here right now. We've got x squared and we've got x. Okay, right now we have it set equal to 0. But let's say that was y. Go to switch y and x, we've still got two y terms. It's going to be more difficult to solve for that way. So to make our lives easier, we're going to convert from standard vertex form, because when your quadratic is in vertex form, there's only one x value, one x term, I should say. Okay, I'm going to go through this process with you. First one. Okay, so step 1, we're going to take the first two. Everything needs to be on one side set equal to 0. It's already set up that way for us nicely. Okay, we're going to take our a and b terms. We're going to put parentheses some unknown constant, okay, to create this new trinomial. Okay, we're going to figure out what that blank next step, but right now we don't know. So we need to create a trinomial. We're going to be able to factor, create a binomial square. That sounds like a lot of terms, but the hang of it after we do it. Have plus blank in parentheses. Now that 28 is still there. It's outside the parentheses. And if we add some number to this, that would change the equation, wouldn't it? We don't want to change the equation. We want to keep it the same formatted. So to keep it balanced so it's actually still the same equation, we need to also subtract that number on the outside. Okay, so we're adding some number but also subtracting it. So overall, we're not changing the equation. We're just reformatting how it's written. Okay, so step 2 is going to be to figure out what goes in that blank. Okay, and to do that, we do b divided by 2 squared. Okay, so you should highlight or bubble in or box or do something to make that stand out. That's a very, very important expression, because that's what we're going to use every time we need to compare. So what is our b value? 12, negative 12. Make sure you get the sign with it. Okay, so b is a negative 12. Divide by 2, square it. Divided by 2, that's negative 6. Squared, that's 36. That is what gets plugged in those blanks. Then I'm a little bit of simplifying. I'm going to say my new trinomial is x squared minus 12x plus 36. And on the outside, I can do combining like terms. Simplifying. What's that going to reduce down to? Minus 8, right? Okay? Now, the whole point of creating this new trinomial and figuring out what numbers should go there, that 36, was so that we could have a trinomial that's going to factor into identical binomials. This takes it way back to factoring. I know we did a factoring review last semester, but remember when you're factoring a trinomial, okay, so the lead term x squared factors to x times x. Now, what are the factors of 36 that would add to 12? Yeah, -6 and -6. Because -6 times -6 would be positive 36. -6 plus -6 would be -12. Okay, and then I've still got that -8. Now, notice it's identical to itself. Something is multiplied by itself. What's actually being done? What's that called? Squaring it. Okay, so this x minus 6 can be written as the binomial squared instead of actually writing it out twice. Of your -8. Now we have vertex form of our quadratic. There's only one x term instead of two x terms, right? So now y equals this. We would be able to switch the x and y and solve for y relatively. Okay, and we can see the vertex now, right? What's the vertex here? Positive 6, -8. Remember, it's the opposite of what's inside. So if you prefer this method to what we did last week, or it might have been the week before, I lose track. But when we had standard form of a quadratic and we had to give the domain and range, we had to figure out the vertex so that we could give the domain and range. And to do that, we did the x is equal to negative b over 2a. Remember that? Okay, so you could still do that process to find the vertex, or now that you know completing the square, you could do this and see the vertex, and it will come out the same. Now this looks like somewhat of a lengthy process, but I'm about to show you something. This number, this -6 that we got as the factor here, where it was the square root of this number and half of this number, right? Well, we came up with this 36 by squaring -6, which came from having the b value. So this number here is always what ends up here. So you're going to be able to skip straight from finding your b divided by 2 squared to your final vertex form. Okay, so it's going to get a little shorter now. We have x squared minus 10x plus blank plus u. Outside the parentheses, plus 30 minus blank. Now we need to figure out what goes in that blank. We do b divided by 2 squared. What is our b value in this one? -10. So -10 is going to go here. So that would be -5 squared is 25. So people are like, well, why do you even have to square it if we know it's going to be a -5 in the equation? Well, we know that part's going to be -5, but we still need this outside number, which that 25 is going to affect. We have to combine it with the constant out there. Still do need to find that. Find those like terms there, but inside the binomial, x minus 5 squared, and what's 30 minus 25? Plus 5, right? There it is in vertex form. Does that make sense? All right, let's try one more. Okay. Our new trinomial. plus 177 outside minus 1. Divided by 2 squared, my b value is what? Is 18, right? So you get the sign with it. Negative 18. Negative 9 squared would be 81. 81 trinomial factored out, x minus 9 squared, outside, constants combined to what? 77 minus 81. Positive. You feel okay about that process? Okay, so now that you know the shortcut, you really might prefer this to the negative b over 2a process of vertex and having to then plug that x value back in, get the y value. This might be easier for you. Okay, so you have a couple of options on how. Okay, any questions about completing the square, this actual process? Okay, so now we're going to take that and use it to help us find inverses of quadratics when they're in standard form. So the first thing it asks us to do is state the domain and range of the quadratic, and then we want to calculate the inverse by using square, and then give the domain of the inverse. Okay, so first things first, I can't give the domain and range until I know the vertex, right? Well, I mean, I could give the domain. Quadratic, what's the right? But I can't give the range until I know where the vertex is. So I'm going to do the completing square first. Plus line 7 is outside, minus 1. Value 10 is 5. So that means x 5 squared. Now this is f of x, or I'm going to call it y, and the inverse. Highlighting the so this is the given function. It means the vertex is there. The vertex of this quadratic. Positive 5, negative. Very good. Quadratic open up or down? Is this a maximum or a minimum? How can you tell? By the a value, right? Positive or negative? This is opening up a minimum value. So the domain we said already would be all real numbers. What about the range? The vertex, what's the range? Negative 8. Now, what we were talking about yesterday in our inverse notes was whatever the range of the original function comes out to be, all right, so this range of the original given function, that's going to end up being the domain of the inverse function, right? Inverse functions x and y switch. Range is y, so inverse it will be x, domain. You already know the answer to that piece, but this is a multiple choice type question. You might be able to eliminate some answer choices knowing that this is going to be the domain. Okay, but we do still have to give the inverse function because that was part of the question. Okay, so I'm going to take this and I'm going to switch the x and the y. It's going to be x equals y minus 5 squared minus 8. Okay, I want to solve for y. So what am I going to do first? Add the 18 to both sides. So x plus 18, y minus 5 squared. Now what? The opposite of square is square root. We talked yesterday in our notes, square root, we're in the habit of putting plus or minus in front, but when we're doing the inverses, we're not going to do that. I'm going to give you a graphic in a minute. Anyway, so we have root of x plus y minus 5. Now what do I do? Add the 5. That would be 5 does not combine with the 8 radical, the plus 5 is not. That's y by itself, so that is my answer. Now, if I want my inverse to actually be a one-to-one function, this is it. Okay, and my domain is negative 18 range there, so that's the domain. Let me give you a graphic. The square root function shifted, let's see, less 18 up 5. Like this, right? Does that shape look like the inverse of this shape? The reflection of, because this was over at 5 negative. If I reflected this over, this is what it would look like. Part of it here, right? Okay. The reason that that wasn't graphed is because we only took positive square root. This to be an actual one-to-one function. Now, if we're not worried about it being a function, if we're finding the inverse, then we can actually include this, and we would do that by putting a plus or minus in front of the radical. Okay, so it's no longer a function now, though, right? It doesn't pass that vertical line test. But that is technically the inverse of this quadratic. Now, had the quadratic domain been restricted to just one side of the parabola, you have just one side of the square root curve as well. But it didn't. It narrowed that domain down. And it includes. Okay. Now that doesn't affect the domain. The domain would be negative 18 to infinity either way. The range here, if we did minus, it would be from 5 to infinity. But we know based on the original function, it should be all reals, right? Okay about that one? Okay. So I'm going to give y'all a couple of minutes to try that process. What you come up with here, Since they are not telling us the domain is restricted here, go ahead and use the plus or minus in front when you do your calculating. Okay, so be sure you include that plus or minus. Okay, so I'm going to freeze the screen so y'all can't see me working it out. I want y'all to give it a try, and then we'll go over it about 2 minutes. Let me try that process. Start by completing the square. If you're watching this video, pause here, try it, and then we can come back to the video. You'll finish completing the square. So what did you get for the range of the original function? Good. Are you still working on the inverse, or do you think you have it? Got it? Okay. Here's the screen. We can check. All right. So my work on the left side of the screen, you can see I did the completing the square and got x plus 4 squared plus 4. So that makes the vertex -4, 4, which the domain would be all reals because it's a quadratic. The A is positive, so this is opening up. My domain would be, or my range would be from 4 to infinity. Okay, now when I switch the x and y here in red, and then I solve by subtracting this 4, so I get x minus 4, and then I have to take the square root to get rid of that square, and I put the plus or minus, because I know that a domain of this one was not restricted, so I'm not going to restrict it here either. Okay, so plus or minus square root of x minus 4 is equal to x plus 4, and then I have to subtract that 4. Make sure you realize that 4 being subtracted over is outside the radical. So you have a minus 4 inside and a minus 4 outside, making your vertex at positive 4, negative 4 here. Okay, and that's what the graph would look like. The domain would be from 4 to infinity. The range would be all real. Okay, so that's putting together what we learned today, completing the square with what we learned yesterday about inverse functions. All good? Okay. Stop this video.